Hello guys, I'm Chris Bowden.
And I'm Paul Kidwell.
Welcome to the Geek Group. Today we're going to be doing the first part of our mini SSTC series. In today's video, we're going to teach you how to build this little jumper. It's the interrupter. So here's a look at it. And what this is basically a device that converts audio signals into light. So you store your music on here or play your music through here or any other sounds you want to send to it. And using this right here, which is a little fiber optic transmitter, this sends the signal out to the coil itself. The reason we do this over fiber optic is because that way there's no direct electrical connection from the high voltage side of things to the low voltage side of things, and this is absolutely safe. It's just powered off a little wall wart, and it's all very low voltage electronics. This is good and safe and an excellent beginner's project for the series. Now you can either store your music on here on this little micro SD card, and this just pops right out. You can put in different size cards, or you can actually connect this to a Midi keyboard. This is a Midi input plug. Midi is the musical instrument digital interface, and you can simply plug a keyboard right into this and play music right through it. So it only has one control. It's got a button, and the readout is very simple. There's only 2 LEDs, and that's all you need. This is a very, very simple little board, and once you assemble your board, it lives on top of, you just go and get one of these. Now, Mr. Kidwell, what is this bottom board?
That one in particular is a Maple. It's a Arduino compatible processor.
Okay.
It's running at, I think, 75 megahertz, so it's a lot faster than a regular Arduino is.
Okay.
And its speed lets the thing process the higher frequency notes.
Okay.
More efficiently. You can get a wider range out.
And this also, you'll notice on here, there's no power connections of any kind. Well, there are, but they're just these pins up here that are labeled like, you know, V in, ground, +5, 3.3, things like that. This is actually the power source for our board.
Right.
And it feeds it up through the pins out here.
Yeah.
So that's your power.
Right.
And your USB, and this is for a battery, if you want one, I'm guessing?
Yes.
Okay.
That board can run off of a LiPo battery as well, but
so you've got all kinds of options.
You got all kinds of options.
Okay. So this is just a buy thing, and how much do these go for?
That's $45.
Okay, so they're pretty cheap.
Something like that.
Okay. And this is about $50 is what we're planning on selling them for.
Correct.
Because we want to do this and keep it absolutely as affordable as possible. You can buy other solid-state Tesla coil kits, but they cost like $250, and they only make a couple notes, whereas ours makes 12. And we like doing things cheaper and better and sharing them with the world. That's kind of the idea. The big difference is when you buy their kit, it comes fully assembled, and our kit, you actually have to work for it. Mm-hmm. We do not sell finished assembled Tesla coils, and the reason behind that is Mr. Kidwell and I have been building Tesla coils for, God, we've got 20 years in this between us, at least.
I did my first when I was 12.
Okay, yeah, but I mean like doing it at the professional level.
Okay.
So, yeah. And we firmly believe that anybody who wants to should be able to own a Tesla coil, but for safety reasons, the cost of joining the club is you have to build your own coil from scratch. Whether it's a little solid state one or a mammoth 100 kVA pole pig one, the process of building the coil forces you to learn the fundamental safety rules in order to be able to do it responsibly.
Yeah, the little mistakes you make along the way.
You're going to get bit. You're going to get bit.
Often.
And the idea is that we wanted to release a kit where if you get bit by this, it's not going to kill you. With things, once you cross the line from microwave oven transformers, that's really the line. Once you hit MOTS, you don't get to make a mistake twice. And we're fanatical about safety at the Geek Group. It's why we have the amazing safety record we do. So we start simple, we start solid state with the most blistering power off of this thing is maybe 5 volts. Mm-hmm. So you could probably kill yourself with this, but you'd really have to work for it. So yeah. So with that, let's put a kit together.
Sounds good.
All right, I'm going to put the parts over here. So this is what we want to look like when we're done. That's the finished part.
Correct.
And here, since you are a professional electronics engineering kind of guy, and I don't really know how to solder.
You're doing much better.
I'm getting there.
You're going to be really good by the end of the day today.
I will do the monkey work and put this together, and you will teach.
Yes.
Okay, so what do we have here? We've got a couple little chips.
Yes.
Is that like a 555?
No, that is an optocoupler used for the Midi input.
Okay.
And that is I think it's a 1 in or 7
It's
for LS14.
Oh, I got it upside down again. It's ULN2803A.
Okay. I'm sorry. That's a 8-wide Darlington driver.
Okay.
The output pins on the microcontroller don't drive very much,
Okay.
so we're putting that between our microcontroller and the LEDs on the board and the fiber optic driver.
Okay. And what does this do?
That's isolating your electronics on your board from your Midi keyboard.
There's actually like a little LED inside.
There's a little LED and a photodetector
Okay.
in there, well packaged.
And we have this.
That's a diode.
Okay. And that's basically a one-way valve for electricity.
Yep.
We have a little switch, a clicky switch.
Yep. Used when you're playing music off of the SD card. If you don't like the song, you can hit the button and it'll cut to the next song.
I just like the clicky switch.
You like the clicky switch.
This is our little light transmitter.
Yes.
Okay. And we've got an LED.
You got a red one?
Which is, yep, I got a red LED. Now, how do we tell which is positive and negative on the LED? I see one
longer
line is
leg is positive.
Okay. And we've got two LEDs. We got a green one. Okay.
Yes, we got a red one and a green one.
Okay. We've got an anode and a cathode.
Yep.
We have our 5-pin DIN socket.
Yep.
Midi, usually.
That's the Midi input for this board.
Though if you need to replace the power connector on your Commodore VIC-20, that'll get you through in a pinch.
Do the job.
We have a lot of resistance.
Yep.
We have a whole stack here.
The Darlington drivers have a
We've got
resistor on their
3.
input line.
We've got 2.
The LEDs have current limiters, and the MIDI circuit has 2 resistors.
We have our actual board. Now, our board's got stuff on it already. What's up with that, Paul?
For the SD card reader, the socket itself is a surface mount socket.
Okay.
And if you pull that in a little lower, there. Right through those little holes, you can see solder joints.
Yeah.
Even if I was going to send this kit out, with surface mount parts,
how the hell do you do that?
The little chip you can get to the legs. On that socket, you can't. It's not easy. Yeah.
So there's a chip in there?
No, the socket itself is surface mount soldered through those joints.
Okay.
So trying to get that on is like almost impossible with an iron.
So we designed this for beginners, for the hobbyist level. We did the hard stuff that normal people can't do.
Right.
Okay.
The chip, maybe they could do.
Yeah.
But the pins are visible. The socket, you need like a reflow station where you put it in and out.
So there are people that can do that, but that's just mean.
Yeah.
Yeah. We can't expect people to be soldering gurus.
Correct.
We also have a nut and a bolt.
That's to hold the fiber optic driver down to the board.
And we have a whole bunch of little pins.
Yep.
And a jumper.
Yes.
This looks like a little hard drive jumper.
It's exactly what it is.
From back when hard drives had jumpers.
This is true.
All right, so with this pile of stuff, what do we need aside from that?
We need a soldering iron.
And
we
flux.
Need a solder, and we need flux. I strongly recommend flux pen for doing anything. That's the one I use the most. It's no clean, which means the residue left on the board is non-conductive and it's very minimal.
No, low solids, no clean.
Yeah.
Oh, that's also the same label you see on cheap toilet paper.
This is true.
So we have a flux pen, we have solder.
Yes.
Now, what do we need to know about solder?
The solder we have here is a no clean flux as well. It's got flux embedded in it.
Okay.
And it's eutectic grade, which is, it should be bottom left corner, SN63PB37. That's 63% tin, 37% lead.
So don't eat it.
Don't eat it.
Wash your hands.
Wash your
don't breathe the
hands.
fumes, all the
Right.
usual. Okay.
Correct. That's the good stuff to use. There's other fluxes. There's earthen core and rosin core, which actually work better for soldering, but they leave black goo on the board.
So this is a solder you want to use.
It's cleaner. It's easier to work with.
Now I notice we have 2 soldering irons.
Yes.
Is this so we can fight?
Well, yours might be pointier, but
I'm okay with that. So why do we have 2 soldering? Is that just the kit you have?
This is for the head. Well, my station has 2 wands. One's bigger.
Hey, this is a new tip.
Yes, they are.
This is much better than the last time. It's
Bring
not like
down
ground down. The last tip you brought in here was all bent and mangy.
Yeah, I got new tips for my iron. They actually work now, much better than what they were.
And we're at temperature.
And we're at temperature, yeah. It's
Not on the table.
All right.
This is why we can't have nice things. Do it on your arm.
That's good. That's at 700 degrees right now, so.
You can take it. All right, so I have to solder something.
Yes. Well, first we need to put parts on the board before you start grabbing the soldering.
I'm going to start with...
No. What you start with is the small stuff that's close to the board. That way when you put the big stuff on, it's not in the way.
All right.
So
where do we begin?
Now, resistors are a good thing to start with. Diodes are a good thing to start with.
We'll start with resistors. Now, I have a whole bunch of these. I have 8 of these, and I'm guessing these go in the 8 holes down here?
There's 8 holes right there.
Okay.
And I usually bend them. Here, I'll pre-bend them for you.
You're going to pre-bend my resistors?
Yes.
Why does this feel kind of like you're cutting up my meat for me?
All right. These are 1K resistors, brown, black, red.
Okay. And what's the tolerance?
This is gold, so this is just a 5%. I think that's gold. Anyhow, I bend them so the tolerance is on the bottom, so if you go to look at them, it's the most significant bit is at the top, and you read down. And if you look on the board, there's
You can tell he's a professional computer programmer right there.
You can see there's a white ring around one hole,
yeah,
and then a little line, so put the body of the resistor on that.
Okay, I'll start stuff and you start bending.
Okay, and you've got them all mixed up, so I can't tell which end's which.
It's so hard being you.
I brought my magnifier so I can
know
actually see today. I'll put them on as I need them. They're coming for us.
That's a fire truck.
Oh, okay.
You know how you can tell?
How?
Did you feel a building shake when it went by?
Maybe a little big truck.
Did you hear a whale siren?
The police use whale sirens in this city?
Fire trucks use whale sirens.
Okay.
Police use Yelp. But yes, big truck goes by, that's fire truck. When you hear the gunfire of the guys shooting back, that's a cop car. And, welcome to the West Side.
The West Side. I wouldn't even really notice, actually.
Well, that's what you get for living in, the American Beirut. Still not as bad as Flint.
Or Chicago.
Chicago. Okay, so you can see as I do this, I'm just stuffing them in the hole with the resistor body over the white part, the circle on the board.
Yep.
And then I'm bending the leads right off. Don't worry about the leads on the bottom of the board. They're not going to matter. We're going to cut them off later. Mm-hmm. So that's what we've got.
There's your first set of resistors. We
all
can go
nice
ahead
and pretty in a row.
We'll put the other resistors and the diode in as well and then solder them all at the same time.
Okay. So. I have 5 more resistors.
Yep.
And a diode.
Okay, you can go ahead.
I got the diode.
All right.
So you can see the diode right here. There's the symbol for the diode, and you can see it's got a stripe on one end, and the diode itself has a stripe on one end. So you want to line it up so the diode stripe matches the stripe on the board.
Yep.
And then you just push that right through there, like that, and just set it right down on the board, just like that. And then once it's down, hold it down with your finger, and then bend the leads close to the board, either just off to the side, and it'll stay right there. And that'll hold everything in place while you solder it, and if you do it like that, it makes this a lot easier. There are other ways to do it. This is the way that I do it. Now, if you're a serious electronics guy, you probably have like a pan of ice or something like that, and those certainly help, but beginner level stuff, guys. We're starting out simple. So,
okay. I have 3 330 ohm resistors.
Okay.
The 8
these go
were 1K.
These go here?
Yep, those are for the 2 LEDs and the fiber optic driver. The fiber optic driver basically is just an LED inside a little package.
Okay.
So they're all 3 the same.
Now, as you do this, and you can see from the notes, the different color values tell you what the different resistance values are of the resistors.
Yes.
But you can also note that as the kits ship, the resistors come in little groups.
Yep.
And you know that your 8 resistors go here, your 3 resistors go here, and then your 2 resistors go over here. And they all have their little place. And
This board, it's kind of simple. The resistors are in like matched sets.
yeah, we put a lot of work into keeping this absolutely as simple as possible.
Okay. And then the last 2 resistors are for the Midi
These go over here.
connector, and yep, they go over there. And it's the same sort of deal.
Yep. You put the body side of the resistor in over the little circle.
Yep.
Very simple, very easy. Just take your time and do this. There's no rush. A little bit extra time spent at this point to do things really clean and neat will save you a lot of effort later. And you want it to look like it was built by somebody who knew what they were doing. Just because you're a beginner, you don't, the rest of the world doesn't need to know that.
Okay.
I got.
Oh, and you go knocking it on the table after complaining to me. Now, hold on.
Ah, it's flux time.
Yeah, you can't use too much.
Cannot use too much flux.
And
douche it right
douche
in
it
there.
down.
Douche, 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 douche.
Get on the close-up.
Huh? Oh, yeah, sorry. Now,
it's like
a flux pen you can draw it on like this, but when you push on it, it floods it down, and you cannot have too much. Plus, it smells nice. Douche, douche, douche. Douche, 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 douche. Douche, 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 douche.
There you go.
Now, what does flux do?
It is a cleaning agent that's heat activated.
It's like an acid, kind of.
They have them that are acid, but acid will corrode the electrons.
So this is not acid. This is acid-free flux.
Acid. Okay. Correct.
I'm going to get a little bit of solder and just break off a piece.
Just put the roll at the end of the table and just keep pulling on it.
Yeah, but you're a professional.
All right.
Nobody has ever accused me of being a professional.
You want a little bit on your iron. You want to touch the part and the solder, the ring on the board itself at the same time, and then add a little solder and let it flow. And when you get it done, kind of wipe the iron up the wire to draw the excess up the conductor. There you go.
Like that.
Yes.
Okay. You hold the board right there. Just hold it by the outer edges, and I probably won't even burn your hand or nothing. And I will blast right through these and try and keep my head out of the overhead.
I start getting warm, I'm going to be moving quickly.
You have no sense of adventure, Mr.
Stop.
Black. What? Hang on.
I think you just did something you didn't want to do.
What did I do?
You just soldered over that hole.
We didn't need that hole anyway.
Yeah, we do.
Okay. I'll come back and fix that.
Hold on. Straighten your wires up a little bit so they're not laying over other things.
All right. You feel better now?
Yeah. I'll fix that one.
You'll fix that one?
Mm-hmm.
I screwed it up.
Just minor.
The second wire screwed it up. Oh, this is so much better than the old one.
Oh, yeah.
It's really cool when you first apply the heat to it. You can see the flux on the wire like burn off.
Mm-hmm.
It's kind of neat.
It's heat activated. When it heats up, it will actually eat the oxide layer off the metal. So you get a nice clean metal to solder to.
See, this works well because you can make sure they can see, and you can supervise my hackery, and I can just focus on, actually doing it. So teach them about soldering while I do this.
Well, just watching what you're doing. Oh, hold on. When you get that one. All right, you see how you wiped over? I don't want you hitting that pad underneath the wire.
Oh, I'm over it. It's the wire's flying over it.
All right, just.
It's cool. It's okay.
I'm just making sure.
It's cool. I screwed it up once. I'm going to try and not do that again. It's just a little tiny bit of solder.
Yeah, you don't need much.
In fact, if you're doing it really well, I've learned, you'll actually, watch, I have enough solder on my tip that it'll partially fill the hole.
Yep, you just need to add a little bit to finish the hole from being filled.
All right, I'm going to come over here and get this one.
Yeah, I got a nice oval pad on the diode.
Yeah, that's a big one.
The wire on the diode is usually fatter. So let it heat up a little bit before you add the extra solder.
Well, those were going really, really fast.
Yeah, well, this one you got a thicker wire, so you got more thermal mass. Oop, don't go branding me.
You're my little puppy now. Now, what is a cold solder joint, Mr. Kidwell?
If the wire moves while it's solidifying, as the solder cools, it goes from being a liquid to being a little on the pasty side to being a solid.
Okay.
And during that pasty phase, if there's any motion to the wire or the part, you'll mess up the crystalline structure of the metal as it's solidifying. And what it'll be brittle to start with, so any further motion will cause the joint to actually break and you'll lose connection. And it's not a good connection either. You got one more, which is the other side of the diode once you're done with it.
Yeah, I had a wire in the way.
Yeah, you can move that wire.
I wanted to give it time to cool off.
Yeah.
That's what reminded me, hey, I should mention cold solder joints. Now, this one needs a minute to heat up.
Yeah, that's, probably put a little more solder on your iron. You want a little solder on the tip of the iron because its thermal transfer is a function of surface area and temperature difference.
So those are all good. Now I'm going to come back and clean this up. Get rid of any excess solder there.
Okay.
And then heat this up back here. Pull that. I'm going to trim everything down except that one and then clean that up.
Okay.
So I'm going to take them out. Do you have any kind of clippers?
I did not bring tools.
You have no tools?
Nope.
All right. Well, then...
I don't... Unless you got... You ain't going to get
I
it
ain't
down
do with
there.
that. All right. I'm going to go get a pair of nibblers.
Okay.
All right. We'll be back right after this.
I learned how to run a machine shop.
Set up an enterprise-level server.
Program 9-foot robots.
Make lightning!
Edit video.
I'm building a radio station.
Light bulb terrarium.
A high-performance electric car.
I'm a CNC geek.
Computer geek!
Robot geek.
Physics geek!
AV geek.
I'm a radio geek.
Craft geek.
Car buff.
No matter what kind of geek you are, we've got a place for you here at the Geek Group. Come join us. We build awesome. All right, we're back. We have a little pair of diagonal cutters, which are commonly called dikes. And you just cut this right off as close as you can.
Get on that.
Oh, okay, here. We're over here. All right. And you really just cut these off as flush to the board as you possibly can.
Yeah.
And
don't dig into the board. You don't want to scratch traces or anything.
And I'm going to come around over here and clean these off. But you just mow it down. You give it all a haircut. And the cleaner and tighter you can get these, the better. This isn't a very good pair of dikes, but
It'll do the job.
it'll get us through.
You want to look as you're doing it to make sure you didn't leave any solder bridges like that one.
Like that one. But that's why you give it a haircut and then you go through and clean up your work.
When I'm soldering resistors and things like that, I'll actually straighten the legs up as I go to heat them. That way they're coming straight out of the board rather than at an angle. That cuts down on the possibility that you trail over onto something else.
I can see that being handy. These are really terrible dikes.
I got a real nice pair of Craftsman dikes, little tiny ones.
Yeah.
That are also terrible. They're brand new.
And they're Craftsman?
They're Craftsman, and
That's
I don't
usually
like
a good
them.
tool.
I know they are.
You're chirping, Paul.
My phone battery's dying. Low battery. Okay. We're going to shut that off. Power off. Power off. Power off. Heaven forbid I get a phone call and have to buy.
Can somebody look in the autopsy toolbox out there and see if you can get a better pair of dikes? Or end cutters?
End cutters work.
Yeah. Because I think I have a set in there.
All right. For those three right there,
Yeah.
come at it at that angle.
From the side.
Yeah, the side where you got the bend,
Okay.
and you can get a little closer.
A little bit.
Like every little bit helps.
Yeah, yeah.
Okay.
All right, and I'm going to clean this up over here. And I've got this one bit of big ugly over here.
I
and I'm
would
just
have
gonna-
left that on. Oh, you're
I'm
going to
cut off
both
as much
sides.
as I can.
What do you got there, Liz?
What you got? Oh yeah.
Ooh.
I like you. You're my real friend. No, those are way better. These have nice, comfy grips. Oh, they snap. These are way more better. Okay. So now we've got a mess. We don't need that. And I'm going to look at this solder bridge here. Now, how do I get the solder out of there?
All right.
Because I filled the hole.
Right. First off, if there's any little piece of wire left on there, get it out.
No, no piece of wire.
All right. Now,
Do we have any solder wick?
solder wick. I actually am not fond of solder wick.
You just heat it and blow?
Close. I'm going to heat it so that it's liquid.
Okay, it's heated. Really?
There you go.
Did that worked?
There's the solder right there.
All right, that's pretty badass. That was cool.
I've been doing it forever. you learn things.
You just get it up hot and smack it on the table. Get out!
Well, take a look.
It's worked. Look at that. That's tight. All right, what's next?
Okay, we go to bigger parts now. So
Okay.
slide the parts over here.
Well, yeah,
Let's
I got a
see
whole
what we
pile of stuff. What do you
Okay,
want?
now.
You don't want that.
Okay. Let's do the LEDs next.
Okay.
All right, now, last time around,
In development testing, we put one in backwards.
Yes.
Now, you have the line on there.
all right. Well, right off, V in.
Yeah.
See V in right there?
V in.
Goes to there. V in is plus, so the resistors are the plus end of things.
Okay.
So even though there's a little bumpy here on the end, the plus end is next to the resistors.
Okay.
The footprint for the board was for like edge mount or LEDs you'd have on the edge of a board so you could see them from like
Yeah.
the edge.
But that's not the kind of resistors we
Or
have.
that's not the type of LEDs we have.
Yeah.
I kind of went with some nice rectangular plastic ones. So the plus is next to the resistor, so the long wire goes next
So
to
the
resistor.
long, so the LED goes in here. You can see the long wire. It's kind of hard to see it, but you can see that's the longer wire.
There you go.
Okay. So the long wire goes there.
All right.
You line it up to the hole, drop it in. So
And on the last one, what color did we put where?
I don't know.
think you
On
got
the
it
other,
right.
yeah, this is the same as the other one. Do you want green on that side for green?
The LEDs are under software control. You can program them any way you want because
Okay.
we're providing the
So
source code.
the long wire goes towards the resistors.
Yep.
And that's the anode. That's the plus.
That's correct.
And we drop that right down the hole.
Yes.
And you just set them all the way down on there, and then fold your wires away.
I just fold one of them, really. It's enough.
I like folding wires.
Whatever. Okay.
It's a hobby for me.
All right.
I'm a lead folder. All right. I lost my solder. Did you take? I had a whole thing of solder.
Okay. I'm actually, while I'm holding it, I'm going to hold the.
You gonna push down under things a little
I'm going
bit?
to push up on it
All
a
right.
little bit.
So I'm just gonna tin my lead a little there. Come in behind it. Heat it up.
Remember to wipe it up the wire.
Yeah,
There you go.
yeah.
So you get the extra solder gets
Now
left
see, the
on
idea
wire.
isn't just to put solder on the wire. You're actually connecting the wire to the little circle on the board.
Yes, it's an annular ring.
And then draw that away and clean it up.
Okay, better to hit it sideways. It was somebody hitting it like that that actually bent the last one.
Yeah, but it wasn't me.
No,
I didn't do
I know who did it.
I didn't do it because I'm a nice guy. I wouldn't do that to your solder iron. I'm nothing but nice to you.
Okay.
All right,
there
so
you
that's
go.
all four of those.
All right, to get the excess solder off,
I'm just going to cut the wire off.
I know, no, on this,
Oh.
like that. That's actually metal right there, so that's a good place
That's what
to.
it's for?
That's
Okay.
yeah. You notice that one doesn't have a sponge.
Yeah, why not?
That one's for banging the solder off on. Wow, that one really. If you aim careful, you might be able to hit your brownie.
Ooh, I'm all for that.
Get his camera
One for
lens.
Liz.
Get the camera lens.
Okay. All right.
That's like a light.
All right, so at this point we have our LEDs, all of our
LEDs.
resistors, our diode. What's next?
Okay.
You want to do a chip?
Let's do...
You want to do a chip? Or you want to do the socket?
Let's do the chips.
Let's do the
chips.
chips.
Are kind
All
of
right, we'll do the little chip first.
Okay. Now, here, let me...
Now, are these static sensitive or anything? Are these like CMOS devices?
They are not CMOS devices. They're not that sensitive. You could, we could do this on a static mat, but it's not that critical. We're using this near a Tesla coil, so it's not like...
I had a feeling, but I wanted to mention it.
All right. When they're brand new, the legs are splayed a little.
Okay.
So you need to straighten them out. Now, on an 8-pin chip, that ain't that big a deal. But the easiest way is to hold the thing on its side and rock it towards the legs.
Okay.
So it straightens them out a little.
These are splayed a little bit
and
too.
You do both sides, just a little. And I just twisted.
I think you just did it a lot.
I just did.
Wow! No, show them. That's what happens when you do it wrong.
Yeah. There's only one in the kit, so don't destroy it. It can take a little abuse, but...
They're pretty bendy.
Once. You go back and forth.
All right, so while you're doing that, I'm going to point out that if you look on the chip, there's a little notch in one end, and that tells you which end has pin 1.
Yes.
And on the board, you'll also see there's a little notch. And you can't do this wrong because there's only one spot for a chip, so you know if the notch is there and the notch is there, you got this. And it's just a matter of lining it up and getting it in the holes. I might have squeezed mine a little bit too much together. So you can take
Little screwdriver.
your Leatherman, which will work just fine for this, and just...
Oh boy, you squeezed that one a lot.
Shut up. I get excited. I'm excitable, Paul.
Okay, now...
So that's in there.
I would, with the chips, bend one leg at each opposite corner and pick one where it's not going to bend over something else.
All right, so I'll take that. And that's headed right off to here anyway.
Yeah.
So, and this is totally in the clear on this end. So I'll take the one that's totally in the clear and I'll just push that over.
Then go opposite corner.
And then I'll go way down here and I've got a nice clear space on the bottom here.
Yep.
And just push that over. And that'll lock it right in place.
Another reason for leaving as much straight as you can is if later on you got to desolder something, having to desolder something with a bent leg is a lot more difficult than getting it out when they're all straight.
All right, I'm gonna solder these real quick. You gonna hold that?
I'll hold
you
it
good?
for you.
All right,
I'm good.
Here we go. There's a lot of soldering in this.
I'm going to do one thing a little different.
What are you gonna do?
Go.
Why are you doing that?
So you're at an angle to it. You're not going in straight along.
Oh, so I'm not bridging pins as I do this.
Exactly. And again, have a little on the iron and then go in. The idea being the little on the iron will kind of wick out onto the pad and the leg.
And you're just filling the iron really as you go.
There's no pressure involved.
Yeah, you don't have to push at all. You just touch.
You don't push. You just touch. And it's thermal transfer is what you're aiming for. So the little bit of wetness on the of solder on the end of your iron will flatten out on what you're trying to heat and improve your thermal transfer.
And if you can, come in with the iron on one side, like behind it, and then come in from the front with the solder.
Yeah, that way your pin or your part is heating the solder. You're not touching the solder to the iron because that'll heat it up right off when your parts aren't hot enough to receive it. We're getting a little topology on the other side of the board, so when you're touching down, it's making the thing tilt a little.
Is that what's going on?
Yeah.
Okay.
Yeah, I'm down on the table a little firmer now, so.
Okay, are you cool?
I'm cool.
I just want you to be comfortable, Paul. I just want you to be happy. Okay, come in on there. Boom, that's that one. And then we'll finish up the other side. Beautiful. Oh, that one's kind of ugly.
Yeah, when you're done, you do a visual, and you're doing a whole bunch of solder joints all right next to each other. They should all look the same. If you got one that looks a little different, heat it up some more.
Yeah, just come back to it, and if it ain't quite right now, see, these are pretty good. This one's a little different, but that's because that pin sticks out to the side. That's where I crimped it.
Like number 4 and number 5 look a little different to me just on the monitor.
Where are 4 and 5?
From the end.
1, 2, 3, 4.
4, 5, and 6 actually look a little different on the monitor.
Oh, that's, well, here, I'll touch them. I'll heat them.
Yeah. It's
So
like
make
some
sure they're
people
all-
say you should never reheat joints. I disagree with that completely. I
Add
want
a
my
little more
joints
on
to
here.
be nice and make sure there's enough solder. It's like adding a little bit doesn't hurt. Just
No.
don't create a bridge.
There,
Yeah,
I think
that
that's
looks
lovely.
much better.
Okay, now where's our other pin, or our other chip?
Okay, now the other chip is right there.
Okay,
Now
now
this chip is a little different. It's got a dot on a corner.
it's got a dot on the corner, which doesn't really show up very well on the camera, but it's there, and it's
by
right
your
under my thumb.
Yeah.
You can see the little dot
Yep, there it
in the
is.
corner, right there.
So that's pin 1.
Okay,
So you want that at the same end
as the
as
notch
the
here.
notch. Yes.
So there's my dot on this corner, and it goes in my notch. And I'm just going to line that right up. And I do one side and then the other.
Yeah.
That's just how I roll. So I'm going to take that, and I'm going to grab my Leatherman.
And do your opposite corner.
That's off
pin
there.
bendy.
And bend that. And you just got to do this on diagonal corners. Just one. Oh, sorry. Just one there
Yeah.
and one here.
That's
and
perfect.
it's fine.
Yeah.
So hold the board.
Yes, I have graduated to being a Panavice.
Years of college, and you're a Panavice now. You good?
I'm good.
Okay.
On this one, you'll notice the hole is at one end of the oblong.
Yeah, why is that?
I was in the process of making the pad for this, the footprint, and I thought I'd just make the pads bigger to make the soldering easier.
Okay. See, that's the neat thing about us doing these videos. We get to tell the story of why it's like that. Not just how to build it, but why we designed it that way.
Mm-hmm.
And that's cool. Now, you don't want to spend too long on a joint because
Yeah.
you can damage the component, but don't rush it.
Yeah, for chips in particular, those things are thermal sensitive. I mean, you can heat it up enough that you're going to do some damage.
All right.
But the resistors, the LEDs...
Want to do the switch next?
Yeah, you can do
I like the
switch.
switch with its bendy feet.
Yeah, it literally
So-
snaps in. It'll only go in one way. It
Yep,
does-
there's
well,
no
it'll-
way to screw this up.
it'll-
You can put it in this way or this way, and it truly doesn't matter.
Correct.
So you just pop it in. Now, you see the feet on here are bent. They got little bends in them. That's supposed to be like that, and this is designed so that it's just a different type of leg. But if you line the switch up and it's all perfect, and then you just push, boom, it'll
snaps
lock
in,
right in there.
holds itself
and
in
now
place.
that won't, like you can, that won't come out. So this makes soldering it even easier because you don't have to bend your pins or anything. They're already done like that. I wish everything came like that, but it would suck for some components.
The sockets that I have for the beta test kits for the driver, I have bent legs like that.
Okay.
It's what we use for our through-hole chip sockets. On this board, we're not socketing anything because we're not stressing this to the point where there's a risk where we're going to blow up the Darlington driver or anything like that.
Okay.
All right, it's all on the board. And that Darlington driver is 8 wide. We're only actually using 3 of them for the 2 LEDs and the driver. It was just easier to throw that thing on there, and it's, if we progress later and add stuff, they're there and I can just tap off of them.
Okay, so now we've got our 5-pin Midi connection,
Yep.
and there's a lot of pins on the bottom of it.
7 total.
Yep, and we've
Those
got
2 are just mounting to hold the thing rigid at the front.
and you can see that it'll only go in one way. When on there, you should have the plug side or the socket side out there. You just line up the holes, hold it in place.
Okay, if you set that down, you can set it so that the part is on the tabletop.
Okay, you hold that. Thank you, sir. Hey, Paul,
Hey, what?
getting this soldering thing down pretty good.
Yeah, now I'm holding down for you pretty good. Do opposite corners first. Do that one and then do the one that's really closest to me.
The one here by your thumb?
Don't
Right here
do
by your
my
thumb?
thumb.
I think your thumb needs soldering.
Okay, now that will mechanically hold it to the board, so now I can check and see that we're seated down all the way.
Okay.
So now it's on there, you can just go ahead and solder. It's like usually when I'm soldering things, with a lot of pins, I'll do opposite corners and make sure it's seated down good. and then I'll go ahead and solder the rest of it. Now, for these pins, they have a little bit more metal to them, so there's more thermal mass.
Yeah,
so,
I'm noticing it's taking a little longer, and I have to add more solder.
yes, the other iron for what we're doing here might be a little better because it's a slightly higher wattage.
While I agree, I'm done.
You're done.
So,
the one
and then I'm going
close
to
to
come
me
here
needs to
and
be
touch that up a little bit
more.
better.
Yes.
That's good. Okay.
All right, getting close to the end.
Yeah, we're almost done.
Okay, we have.
Want to do this next?
Yes.
Okay. Now this is a two-part thing. There's the electrical, and which is also a mechanical connection, and the straight mechanical connection.
Right.
Now this is a diode inside. I think it's an infrared diode.
No, that it is
It's visible light?
It's a red LED, basically.
Okay. So these two pins, and you can see there's the outline, the little tombstone shape. That's where this goes, and it actually hangs off the edge of the board. Mm-hmm. So you just pop those right in there like that. And
Now, you can put the screw and nut on there right now if you want, and that'll hold it in nice and snug.
you put the screw on the bottom, nut on top.
Head on
or
the bottom.
Head on the bottom. So you put the bolt right through there.
And it's better to do that first because the LED that's in that blue holder will actually slide out, and you mess up the
Really?
line. Yeah, I did that.
You've done this,
once.
Paul?
But yeah, if you screw it down first, then you don't have to worry about the thing pulling off the board or getting
Okay.
it.
And I'm just going to hold this right down to the board, and then with my finger on top, catch my proper thread, and then just screw that in. And that's just the easy way to do it.
Well, doing that particular screw with a Leatherman is not what I would call the easy
It's
one.
not, but it's what I had, and I like my Leatherman. It'll get me through. This is the last video we will ever shoot on this set, well, this little series of videos.
Yeah, so all the tools are
And,
already moved.
Yeah, everything's moved. The whole set's tore down, so it's a little bit weird in here. That's also why the room may sound a little echoey. It's empty. We're one set in the end of a really big room. Mm-hmm. So that's bolted on there, nice and
Yes.
solid.
No, you
And
got-
I don't have to bend these off. These are
No,
fine, just
they're
like
fine.
that.
They're held in place.
You got it. I'm going to put a little heat in there. Come in here behind it. Solder that down nice. A little solder on my iron.
There you go.
Okay.
Now, when you secured it down, you can see there's two blue spots there. There's a couple of pegs on the bottom
Okay.
to help line the thing up. So
you
that
know you're exactly where it should
it's
be.
rigid on
Okay.
there now.
Cool. And now I can trim those leads off. Okay, and this is starting to look like something. Like we've just been hanging out, and it's nice to just take a minute and go, wow, hey, look, I'm building something here.
Mm-hmm.
This is neat.
Okay, now, the next thing we're going to do is the strips.
Okay.
And you can take your cutters. We need two for this guy right here.
Just two?
Just two.
Okay,
give
so
me
just
two
take
to
two.
start with. Take two.
And there's a little groove in this where you can see. So you just cut it like that. And I've got two.
Right.
And I'm going to trim off my little bit ugly there. Because I care.
Now,
There's no polarity or anything, but I put the short side to the board.
correct.
And I just set these right in here.
Now, getting them to stay in while you solder them can be interesting, and you don't want to hold it in with your finger while you're heating it.
Because they're going to get hot.
They're going to get hot.
Okay, so I got a plan. You hold them in with your finger, and I'll solder them. You got that?
I'm going to hold in that one with my finger.
And I'll solder the other one?
You solder the one over here.
All right, but
Hold
you
on.
gotta
I'm
get it
going
on
to
camera
watch. You
there.
go on the wrong one, and I'm going to be
This one?
dropping this. Yes, that one.
Get a little solder. There you go.
Oh, give it a sec. Okay.
Okay.
And we'll let it. Don't go blowing on it.
Why not?
You make a cold solder joint.
It's got to cool off after that, as
It'll
long as it
cool-
doesn't
It'll
move.
cool off on its own. Now, you'll notice it's nice and seated down to the board. We're all
Yep.
good. So now do the other one. If
Without
you-
heating up the first one.
Without heating up the first. If you heat up the first one, the part will fall right out of the board.
Okay.
All right.
And don't
now-
blow on it.
Don't blow.
Because you get a cold solder joint.
Now, take your little jumper and install it on there.
On that one?
Yeah.
Okay.
Now,
This is where the little blue jumper lives.
that is the RX line going to your Arduino.
Okay.
When you're plugged into Midi, actually even if you're not plugged into Midi, your circuit over here that's your Midi receive ties into the RX line, goes into the serial port on the Arduino. When you go to program your Arduino, like through the USB port, that circuitry will interfere. So the simple thing is just to take it's a Midi shield. You pull the shield off of your Arduino and do your programming. Well, rather than do that, you just pull the jumper off and then you can program it.
So you don't have to have it on and off, now. You can just do it with a jumper.
Well, exactly.
Okay.
I use, the Maple processor I use has a separate serial port for programming, so I don't need to take the jumper off. But if you're using just a standard Arduino Uno, you need to take that off.
But for this, you want to use the Maple to get the multi.
To get the, well, you can get the speed for the high frequency.
Okay,
notes.
so now you need to have enough jumper to do the 4 big headers. And you could count it, but what I do is I just put it right in the end and then get enough pins and you're set.
Yeah.
And then just put your thumbnail in there and you know where to cut. And
For
then
the
make
record,
sure,
you need 2 8s and 2 6s.
2 8s, 2 6s. So I've cut that off just eyeballing it.
Okay,
and
now.
there you go, and it just sits in there just
There's
like that.
one slight problem.
What's the problem?
You got it on the wrong side of the board.
Huh? Oh yeah, these go on the bottom.
These go on the bottom.
And that's important to remember because that's easy to screw up.
Yes. Go ahead and get your jumpers cut, and then I'll show you how to do this.
All right, so that's my first one. And I'm going to need my next one. And you can measure them on top because it's the same number of holes on top as on the bottom.
This is true.
So I'll line that up. There's my second jumper. Now those are the 2 8s.
Yeah.
Now on the other side, we need a pair of 6s.
Yes. When they were designing the Arduino, for some reason, they set the distance between those 2 headers at like 1.5 pins. So you can't just run down the whole length and it won't fit onto a standard breadboard.
Okay.
But oversight on their part, I'm not certain why they did it that way.
Now I have extra.
Do that extra.
I got
If
6 extra.
If you can reclaim that gold, you might actually get something for it.
Yeah? There's gold in there?
That's gold.
Oh, okay. Like a billionth of an inch plated.
Yes.
All right.
All right,
So-
now, the way to do this is, no. Grab your processor board.
This one?
Yeah.
Okay. And just put these in there?
Put the headers in there.
Okay, and put them in long side into the board.
Long side into the board.
All the way down?
All the way down.
All of them?
All of them.
Okay.
It's going to wind up on there anyway. But
I see where you're going. You can just stick all these in there and then set it right on top, and it's a nice work holder.
Yep.
So you just line that up.
Now,
You got to fiddle with it a little bit to get it all to line up.
even though the pins have a bit of thermal mass, you don't want to heat these things up so much that you start melting the connector on the Arduino.
That would be bad.
You don't want solder to go wicking down in and solder all the way down to the pins on the Arduino, because then you're soldering your shield onto your Arduino.
Okay.
But this is a valid way of getting the thing lined up and held in
This,
place.
of course, only works if you have your Maple board to begin with.
Or an Arduino.
Or an Arduino.
anything.
But
Okay.
you have to have it. Oh, we're fluxing again. Because we fluxed everything else before, but we didn't do
Well,
that.
we fluxed the resistors. This other stuff we were doing didn't need it quite so much. This, I'd strongly recommend using some flux on this because the pads are big, the pins are big. This, these solder joints are somewhat structural as well as electrical because it's literally holding the 2 boards together. And I don't think you need me to hold anything because
I got this.
all you need to do is make sure the board is down on the pin. And I do, again, either opposite ends, and then check to make sure you're seated good. Now, you notice this is taking a lot longer than the other stuff to solder. You got a lot more thermal mass in the part you're soldering. I'm about to give you the other iron.
Give me the other. Oh, wow, that's big.
Yeah.
That's really big.
It'll heat up a lot quicker.
Oh yeah, that makes life easier. All right,
This
I'm just
is
going to do the outer edges, and then you can check everything. Here, give me a thumb down in the middle there.
This is for stuff like this, the cheap Radio Shack irons are actually pretty handy because what you're trying to solder isn't like real fine stuff.
Okay,
I'll take
double
a
check
peek.
that, make sure you're happy.
All right, you're seated down all the way around.
Is good?
Is good. You can see, I can see the pins on that one.
Yeah, just a little bit. Okay, you want me to heat them up and you can push down on it while I heat it up?
So what I'm going to do, okay, you did 4, but yeah, just heat up all 4 of them while I'm bearing down.
Okay.
Hold on, let me get you on the camera.
You
There
push.
go. I'm pushing.
Here, I can...
What are you doing, too? Oh, you're doing
you know
2.
that thing that Kennedy does where he writes in English and push?
I'm pushing.
All right, there you go. You remember that thing Kennedy did where he'd write in English and French at the same time? Yeah, I'm doing that. There you go, push.
Good.
Okay. That's right, I have progressed from not
Much
knowing how to
better.
solder at all to being able to do it two-fisted, man. Two-fisted soldering.
Here, let me give you a little slack. You're getting a little tangly. You're off camera, so push forward.
Oh, here. Well, there you go. This is way faster.
I actually have a 3rd iron at work, which is a big chisel point that's like twice the size of that. The wand you're holding is a 20-watt wand. The 3rd one I have is like a 43-watt for big things.
I know you're not supposed to breathe this, but I like the smell.
Strangely, there's a lot of workman's comp cases being being filed from what the fumes from flux is doing to people's lungs. It's
Yeah,
actually
I don't do this
worse.
for a living. I do this like once a year,
Yeah.
so I'm not worried about it.
It's actually worse than the lead that you're getting absorbed through your hand right now.
Which is an amazingly tiny amount of lead.
Slide to the right a little.
Oh. Done.
Done.
I think that's totally done. I think that's our
It is.
our whole kit.
That's the whole kit. Now, we can clear some stuff off and get the little Tesla coil over here and actually give it a shot.
Yeah, we can fire this up?
Yes.
That would be awesome. We've got our Midi coil,
Yeah.
and this is all ready to go. It's powered up. It's just sitting there listening. And now the way this works is we've got our fiber optic cable that goes to the coil, and
Right.
you'll learn how to build that in a future video. But if you take a light and shine it in the fiber optic, the coil turns on.
Yes. Do that, yeah.
So you can see it right here. Okay, so what this is doing is pulsing that light really fast. But all this is doing is turning a light on and turning a light off. The whole idea behind this board is it turns a light on and off. So we take our cheap fiber optic cable. This is like 1 millimeter, the cheapest basic.
It's the plastic, it's
Yep.
not even glass.
You don't have to have a special termination kit or anything like this. We really wanted to keep this simple. Just cut it with a razor blade and you're fine.
Your razor blade is your termination kit.
So that's connected into there. We've got it on our maple board.
Yep.
And when you set up the maple board, I'll pop it off here. And we're going to do a subsequent video. This video is just on the hardware. This video is just how to put it together, but I'm going to touch on a couple little things while we're here. Down in there, there's numerous different ways to power this. You can do it from the wall wart, from USB, or from the little lithium battery. And that's where you set your jumpers here. You can see on the jumpers there's external, which we have connected because we're going to use a wall wart. There's USB and there's battery. So depending on which one of these you want to select, just follow the instructions for your maple board. You can do this with an Arduino. I really recommend doing it with the maple because it'll do higher frequencies, it'll do more complex algorithms, and that's really what we're showing off.
Yes.
We're the only kit out there that can do this.
We're at 75 megahertz for that process.
So you line it all up, pop it in, seat it right down. You are now assembled and ready to go.
We got the USB card in?
Yep, micro SD card. We've got our micro SD card in. This card has all the software and everything on it. It's got the music on it. This is an older one from when we were doing for Christmas.
Yep.
It's after Valentine's Day now. So,
yes. We need to redo that little...
We need more music.
We need more music.
So, and we will make music files available on our website for you to download. Yes. But you can certainly make your own. So you simply plug this in, and it fires up. You'll see a little light down in there flashing.
Yep, that's the bootloader.
And now it's going to come on and start playing music.
One would think. There you go.
I wouldn't want to rush you. Are we still in MIDI mode?
I think you're touching pins on the bottom is what it is.
I'm touching pins on the bottom?
Yeah, it just reset itself.
Oh, okay.
There.
And it plays music. There you go. And if you hold the button down, it skips to the next song. Well, if you hold the button down, it just shuts up. But the idea is that we could talk over it because it's very loud.
Yes.
So, and this is just, a little taste of what it can do. Now, there are other kits out there that are perfectly functional musical Tesla coils. There's even other kits out there that can play more than one note at the same time. The reason we use this particular board with the higher processor is so that we can play 12 notes at the same time, and you can hear it. It's playing full chords.
Yeah. You're hearing these pieces of music are 4-note harmony.
Okay.
It came from choir music, actually. Old Christmas sheet music.
Yeah, this starts out really simple. And you can definitely hear the multi-part harmonies in there.
The first song on here that does more than 4 is Toccata in Fugue in D.
Yeah, which gets insane.
Like 6-note, 8-note, and 10-note chords in there for the big, huge chords that are being played. But I think that's 8 songs in on this playlist here.
Now, how long do you have to hold it down before?
Just a half a second should be enough. Until the green light comes on, that's when it realizes. And there's a 2-second delay from when you release the button to the song starts.
Okay.
So. Portal opera. Two different versions of that sheet music available, so I did both of them. There you go.
So here's the Toccata in Fugue.
Yeah. That was an 8-note chord right there.
That's 8?
That was 8. The next big chord is a 10. I can't get low enough.
So that's
last,
10 right there.
That was a 10, and then the last one was an 8.
Okay, and it just grinds right through it, no problem. It can handle it.
We can plug in the MIDI connector to a keyboard or
I'm going to unplug it to stop screaming at us, but...
We can plug into a MIDI keyboard or a PC and play MIDI files direct from the PC.
Through like a USB to MIDI converter kind of thing?
That's a $5 off-the-shelf item.
Yeah, we've got some in stock.
You need to send the keep alive signal from whatever your MIDI device is, because if you unplug in the middle of a song, MIDI works with note on, note off.
Yeah, so if you unplug, you'd have a note on with no note off.
And the thing would just sit there. So after a couple of seconds, if it doesn't see the keep alive, it'll shut itself down just for safety's sake.
Okay.
So
we built that into it in the software.
That's in the software,
okay.
Yeah. When you're playing a MIDI file from a PC, some of them can be rather complex. The only one that gave me any trouble was a full orchestral version of Little Drummer Boy. I don't know how many notes it was trying to play at the same time, but I think it was somewhere over 15 or something. And at that point, the board just shut up.
It just couldn't handle it.
It went into a safe, I'm not doing anything state until it got to a point where there were fewer than the maximum number of notes, and then it started playing again.
Okay, so it's really designed fail-safe in every possible way we can think of it. Okay. You're going to be able to find all kinds of software available for this on our website. There's going to be a lot more videos in this series, but now you know how to build it. Yes. So at this point, you have your hardware, and now it's time to start building your other parts of your hardware, like the Tesla coil kit. So that's the next video. You guys have fun. I'm Chris Bowden.
And I'm Paul Kidwell.
You can find more information at thegeekgroup.org, and if you're not a member yet of the largest hackerspace in the world, you should be, thegeekgroup.org. You guys have fun. We'll see you next time.
This video was made possible by a grant from the Future Girl Foundation.
This video was made possible by thousands of private donations from members and viewers like you. Please visit thegeekgroup.org for more information on how you can donate and become a part of our dreams of Avalon.